Let's do number 9. What's the equivalent capacitance between points A and B? So the problem is asking us to simplify the circuit. So I'll just read right here since there's not much room. So this is the original one that we are given. And all the capacitors have the same capacitance. So the first thing is to see what can we simplify. Well, I noticed that these two over here are in series. So I'm going to redraw the circuit, and I'm going to simplify these two here in series like this. So these two become this one, and I haven't touched this one that was down here. And when I do that, I'm going to go ahead and find the value of this capacitor. So if I have these labeled as C1 and C2 and C3 and C4, then this would be C1, 2, which is the combination of 1 and 2. This would be C4 and this would be C3. So when you combine capacitors that are in series, you have to use the 1 over C equation. So 1 over C12 is 1 over C1 plus 1 over C2. These are all 1, so when you plug in 1 for C1 and C2, you get 1 over 1 plus 1 over 1, you're going to get 2, which means that C12 is going to be the reciprocal of this, is going to be 1/2, or 0.5 microfarads. I don't put the microfarads until I'm done plugging in the numbers into this equation, because it'll come out to microfarads because everything is in microfarads. And just FYI, it turns out that if you are ever combining two capacitors in series that have the same capacitance, then that equivalent capacitance is going to be half of the capacitance, right? So the next thing is to see that these two capacitors, 1, 2, and 3, are in parallel. So I'm going to draw this again and replace these two by this one, which is now C123. So you can see that they're in parallel. This end is connected to this one, and this one is connected to this one. And when they're in parallel, it's easier to find the capacitance. C123 is going to be equal to C12 plus C3. So you're going to be doing this one was 1 plus 0.5, right? 0.5 plus 1, you're going to get 1.5 microfarads. And finally, we have one more step here. Now we have two of them in series that we're going to combine to our final equivalent capacitor. So this is C equivalent, the final one. And these two were in series, so we have to use this equation again. 1 over C equivalent equals 1 over C123 plus 1 over C4. So we're going to plug in 1 over 1.5 plus 1 over 1. And when we do that, I don't remember what we get here. I don't have a calculator. But when you solve for C equivalent by doing 1 divided by this number that you just got here, then you will get the 0.6 microfarads. So whenever they're in series and you're finding that equivalent capacitance, make sure to find the reciprocal of that answer. Let's do number 10. Similar thing, just a different configuration. So for this one, what we see is that we have these two here in parallel, and then these two over here in parallel. So if I go ahead and redraw this, then I can actually do both of these at the same time. This doesn't happen very often, that you have two different sets of capacitors that can be simplified at the same time. But you know that when you have capacitors in parallel, that to simplify them, you just add them. So you can just find here this equivalent capacitance. If you call this C1 and C2, this would be C12, and then that would be C3 and C4. Then you're going to simplify them to C34. And C12 is just C1 plus C2 because they were in parallel. So that gives you 40 microfarads, the 20 plus the 20, and then the C34 is going to give you the 30 plus the 30, the C3 plus the C4, which is going to give you 60 microfarads. And now you have two capacitors in series, so you have that equivalent capacitance, and you're going to use the 1 over equation to get this C equivalent. So 1 over C equivalent equals 1 over C12 plus 1 over C34. And so plug in 1 over 40 plus 1 over 60. And again, you're going to get some kind of number. But then to find C equivalent, you do 1 divided by that number, and you're going to get 24 microfarads.